Good morning, everybody from sunny Edenbridge, and welcome this morning to a webinar introduction to commercial audio. I'm Justin Martin Lawrence, Technical Manager at Habitech Limited, and I've been in the industry for 29 years now. I manage all aspects of technical at Habitech, which includes everything from liaising with manufacturers, looking at where the future is in terms of the technology we use. And I also write and run the majority of our IP, audio, video, and integrator training courses. Currently, I'm also running the technical support desk during the COVID-19 outbreak. This is an introduction to commercial audio. It's a presentation based on our full-day commercial audio course, squeezed into what will hopefully be a useful webinar for you. Obviously, there are some aspects that I'm not going to be able to cover, for example, hands-on with processors and so on, but I will try and give you as much technical information as possible. You'll also receive the presentation in a link, and you'll receive other documentation appropriate to this training too. That link should come out to you within 2 days of the webinar. If you've got any questions at all, please do send them to training@habitech.co.uk. It's very useful for us not only to get feedback, but also to see what questions come along so that we can try and gear our training and make sure it covers everything you'd like it to. Before we start, a little bit of webinar lore. For those of you unfamiliar with using the Zoom platform, you'll find if you move the mouse down towards the bottom of the screen, the settings pop-up will appear, and on the bottom left-hand side you have audio settings. So if you're having difficulty listening to or hearing this webinar, it could be because of the settings you have there. We also have a Q&A panel. Jonathan Pengilly is going to be my co-panelist today, and we're going to take some breaks during the webinar for questions. If you do think of a question, please use the Q&A icon. It's the best way to get an answer, and avoid using the raise hand button. Try and avoid using a chat window if you can, as it obviously can be distracting for other people. The chat window button invokes a window which pops up, which can make things a little bit difficult to focus on. So our agenda today, what's different about commercial audio, commercial audio applications, audio transports and applications, impedance and cable distance, audio guidelines, specifying a system. Then we're going to run through the system components and accessories, and I'm going to give you a very brief overview of the Yamaha MTX and MRX software. So what's different about commercial audio? Well, first of all, it generally covers a larger area. Commercial audio projects often cover a significant bigger area than a typical stereo system, and quite often are monaural. It generally has 2 or more speakers, and they're quite often wired monaurally, as I said above. Many commercial applications have different volume requirements in different areas. And generally speaking, commercial audio often has multiple signal sources. And some of those sources are devices that you wouldn't get on conventional residential audio, such as microphones, timed announcements, and remote volume source control and inputs. Where are the opportunities? Well, I can tell you from personal experience that commercial AV has enormous opportunities in our business. Many of you will be familiar with customers that are generally self-made, and those customers have businesses. So quite often, commercial AV is a good way to get business expansion into your customers' businesses. Most commercial applications have multiple AV and networking requirements, so they generally spawn much further out of audiovisual into a much bigger affair. And commercial AV systems are scalable. So you may start with a smaller system, and you'll find that if you deploy it well, you'll be back to expand that system in the future. From a personal perspective, one of the things I've identified with commercial AV, and specifically our offering at Habitech, is that there really is a void between the top end of residential installation and professional commercial installation, where there are companies that are tendering for very, very large projects in the likes of shopping malls, hotel chains, etc. There's a big void with smaller businesses that may only have one or two sites, which can grow into bigger sites, which both of these industries at the moment are missing. We've seen enormous growth in commercial AV with very, very limited advertising. So what are the applications for commercial audio? Well, what I've done is I've broken it down into 5 different sections. There are obviously more, but principally, my view is it starts at small bars and coffee shops, moves into restaurants and hotels, gyms, places of worship is a particularly large growing environment at the moment, and conference facilities. And I'm now going to run through each one of those in a single slide, just to give you some ideas of the application that you would be using commercial audio for. Before we do that, let's have a look at the general considerations. And these are things that you need to consider when you're planning to deploy a system. The first one is the size of the application, because that's going to govern the speakers and the amplification you're going to use. Then we need to consider the speaker distance, because there are several different ways that you can wire a commercial audio system. And I'm going to run through those in a little while. The number of sources you're going to use. Are you going to require microphones? Is it just going to be a CD player or a Sonos-based system? Is the application stereo or mono? Perhaps in smaller venues like coffee bars, it's fine to have stereo. But when you grow into bigger environments like hotels or conference facilities, stereo is generally considered a no-no, and you would want to be using mono. Are different volume levels required? Because if they are, then you're going to need a different or more complicated amplification and processing stage. And finally, as I mentioned above, does the application require a microphone? So let's start with small bars and coffee shops. They're most likely going to be offering background music, and they're going to, whilst they might be very quiet at the moment, they're going to be a massive opportunity for business, because business owners know that it is actually the appeal of the venue that draws clients in, not just the taste of the coffee. So it's most likely background music. It's probably one source, and that source is likely to be something like a Sonos or a Musicast-based system, perhaps Spotify. You need to be very careful when you're specifying this to look at the commercial options for streamed music. There are some subscription-based services. There is also a dedicated service from Spotify, which your clients would need to license if they were playing music in a public environment. Small bars and coffee shops will generally have short speaker runs, and stereo may be a requirement depending on the venue. Moving on, we might introduce a DJ, and in that case then we may want to consider wider volume expectations. So we're going from background music to midground and foreground music, probably still only using one source, probably still having relatively short speaker cable runs. Stereo may still be a requirement, but you're probably also going to need to allow for an input plate or some kind of method for the DJ to hook into the system locally without ripping the setup apart. Restaurants will most likely require background music, and again will probably only be one source. They may have longer speaker runs, so you may need to consider high voltage applications. Stereo channels, generally speaking, are not used in restaurants, so you should either sum stereo inputs, which you can do in processing, or you can parallel the left and right together, assuming the input impedance of the amplifier is happy with that. Generally speaking, they are. You're going to have multiple speaker applications because you may want pendant style speakers above high areas, but you may also want wall mounted speakers or corner mounted speakers as well. Because of the layout of restaurants, you're also going to find that you're going to need different volume levels. A consistent volume level throughout a restaurant quite often doesn't result in the same volume level being heard by customers because of the way you have to place speakers, or if, for example, a booth is tucked in a corner and you have a speaker above it. So generally speaking, you would use a multiple amplification for areas, and you would be able to adjust the amplification for the areas. You may also have different menu choices and menu styles during the day, which would require different volume and perhaps different music styles. Hospitality, like boutique hotels, will definitely want background music, and that's probably only going to come from one source, and it's likely to be streamed or a playlist that the hotel has put together. It will undoubtedly need microphone inputs, and these may be for car park announcements or general staff announcements, but they may also be for venue facilities for wedding banquets, etc. So you're probably going to want to put in multiple input plates in conference and venue rooms. They will undoubtedly have longer speaker runs. You definitely want to work in mono, so stereo channels should be summed. There'll be multiple speaker applications because, as you can see from this picture, there are obviously going to be different heights and levels and applications for speakers. And you're definitely going to need different volumes in different areas. In leisure, specifically in gymnasiums, you're going to want louder music. Again, one source. Very, very often the leader will want to use their own source equipment, so you want to provide something that makes that easy for them. You can, for example, provide Bluetooth plates, so they can just connect their iPhone or Android device. You can add microphone inputs. You will probably want to consider radio mics. Again, a lot of presenters will want to use body packs rather than handheld mics because obviously there's a lot of physical activity. You'll probably need longer speaker runs, and stereo channels should again be summed. The other thing you might want to consider, and this is where you probably want to use some of the more complicated processing products that we sell, are things like partitions, where you might want to make, quite often gyms make larger areas into smaller areas, and you can have triggers, for example, that will adjust the scope of the application automatically according to doors opening and closing. You're definitely going to have multiple speaker applications, and they're going to be very wide. So you're probably going to be going everything from background music right the way through to high-level PA. So you need to allow for that. And undoubtedly, there will be different volume zones. Houses of worship are a very fast-growing part of consumer AV, commercial AV. Generally speaking, they're very difficult acoustic environments because they have high ceilings, they're old buildings, they generally have very little fabrication other than perhaps a small runner. You need to allow for multiple microphones because quite often services are deployed differently according to the time of the week and the time of the day. Quite often, priests and leaders will use laptops and DVD players. So you'll probably want to include some kind of video streaming and distribution service. That might be ClickShare, AirPlay, Chromecast, ScreenLink, etc. You're probably also going to want to consider a video switch. And this is an ideal application for our AV over IP products because churches and houses of worship are, generally speaking, very, very large areas with long cable runs. And video is very intolerant to cable runs over about 60 meters, whereas by using AV over IP, you can extend up to kilometers using fiber as necessary. Also, you'll find that cable runs aren't very easy, where normally you might hide cables under floorboards through joists, etc. In a residential installation, most houses of worship are beautifully decorated and designed, and they don't want Cat5 nailed up the walls or sticky conduit. So quite often you have to take elaborate cable routes to get from one point to another. You're definitely going to want to allow for auxiliary audio sources and sockets, because quite often they will run concerts and music venues, and they're definitely likely to require microphone inputs as well. Also consider wireless microphone applications. Again, it's very common for priests and leaders to use body pack microphones, either lapel or cheek or air mounted. And without doubt, houses of worship have longer speaker runs. So you're almost always going to be using a high voltage system. Finally, corporate facilities. And again, this is a very, very growing part of our industry. More and more companies are doing large corporate presentations or themed events. They will often have guests. So you'll need to allow for multiple microphones, without doubt, some kind of audio and certainly video from a laptop, and that might be ClickShare, AirPlay, Chromecast, ScreenLink, etc. Again, it's a very good application for AV over IP, and at the very least, you need to consider a video switch, and also consider the compatibility of the devices that are going into these events. One of the biggest problems that people have is that when they're at these events, they're already pretty highly strung. They're very tense from the setup. They have talks to give to large audiences, and failure really isn't an option. So you need to make sure that you cover every adapter, every conceivable audio-visual input, so that the lecturer or guest can very easily connect their own equipment. Very definitely going to require microphone inputs. And again, you would probably want to put these as wall plates in addition to providing some kind of wireless service. And they may have longer speaker runs. Next up, I'm going to talk about how audio transports work, because unlike residential, we use two different types of speaker cabling, we use different types of amplification, and we also behave very differently in the way audio is input into devices. In smaller installations, you're generally going to be using a low impedance system. Low impedance is the same standard that we use in consumer audio. So for example, any AVR will be low impedance. And it refers to the AC resistance of the loudspeakers that are connected to the amplifier. So in conventional terms, low impedance normally means 8 ohms, which is the average in-home or home cinema speaker. It can reduce down to 4 ohms in some speaker applications. It's very important to understand that the lower the impedance, the higher, the harder the work it is for the amplifier that it's connected to. So if you have an amplifier designed for an 8 ohm load and you connect a 4 ohm load to it, then you're going to tax that amplifier, and its likelihood of failure is going to increase significantly. Thankfully, today, the majority of amplifiers actually use Class D amplification, which is much, much more tolerant to lower impedances, but I'll run on to that in a little while. You can add additional speakers by using series or parallel wiring, and you'll find even in the smallest installation, you're probably at the very least going to want loudspeakers, at least in each corner of the venue. Cable runs that exceed 25 meters aren't recommended, because the further the distance a cable runs, the higher the resistance it presents, the less efficient it is for the amplifier to drive. And eventually you reach a point where actually the higher treble frequencies and lower bass frequencies roll off due to the distance and absorption in the cable. Basically, when you run any kind of current down a cable, there is an efficiency of the cable where, or inefficiency really, where some of that current is dissipated in heat. Not heat you can feel, but the cable does actually warm up according to the load that's being driven across it. Conventional low impedance amplifiers and receivers generally lack flexibilities and options. One very good example would be in this small bar, where we could, for example, install an AVR, but not have a microphone input that we could use. So you're better off using something that is actually dedicated to that purpose, even if it's a small application. There's also a technology called audio ducking, where use of the microphone will automatically make the audio that's playing dip for a period of time while it's playing. And again, in some applications you can mix this, and in others it's an automatic function that you preset in the setup. You won't find those kinds of facilities on residential amplifiers. So at the very least, you should be looking for something like the Yamaha MA2030, which is pictured in this diagram. And what I'm going to do later on is I'm going to run through the different amplifiers and processors that are available. In our smaller installation, we generally recommend low impedance, but we also recommend a maximum wiring distance per output. And the table, which I'm not going to read you verbatim because you're going to get a copy of this presentation, gives you an indication of the cable you should be using and the maximum recommended cable distance. And you'll see, surprisingly, with a 16 gauge cable, the actual recommended distance is only 14.8 meters. And I can hear you all scratching your heads thinking, well, hang on a minute, last week I did an application where I had a 100-meter speaker run. Yes, of course, 16 gauge cable will work over 14.8 meters, but it exceeds its audio optimum at that point. As the resistance or the load to the amplifier increases and the resistance decreases, you'll see that those distances, cable distances run right down to 7.3 meters for a 4-ohm application. So generally speaking, we'd recommend you install at least a 14 gauge cable. It has a bigger wire cross section and a significantly lower impedance. And you'll see that that 14.8 meters reaches nearly 25 meters before any audio loss on a 14 gauge cable on an 8-ohm system. In terms of wiring speakers, there will become a time, for example, in the coffee shop I just showed, the small bar I just showed you, I mentioned that perhaps you'd want to put speakers in each corner. And that means either doubling up on amplification, or you can use series parallel arrangements to adjust speaker runs and therefore add a speaker per output. So in the case of our MA2030, we could actually run 2 speakers off of each channel on that amplifier. It's a 2-channel amplifier. And we could do that by running the 2 8-ohm speakers in parallel. Now, when you run speakers in parallel, the impedance actually reduces and the load to the amplifier increases. So what will happen is, once those speakers are wired in parallel, the 2 8-ohm speakers, they will become a 4-ohm load. Now with the MA2030, it's a Class D amplifier, and it's quite happy driving a 4-ohm load, so that's not going to present any problems. With other amplifiers, you might have to run a series speaker wiring application, and this is where you actually connect the negatives and positives in series of the speaker loads, a little bit like putting batteries in series in a circuit for a torch, for example. When you put speakers in series, the load to the amplifier actually increases, and in this case we'd be presenting the amplifier with a 16-ohm load. By presenting a higher impedance, it means that the volume level will actually decrease across the zone. And at maximum volume level, the amplifier will be giving less output than it would be if it was running a lower impedance. So generally speaking, you don't run speakers in series unless the amplifier is very sensitive. So if you have an 8-ohm amplifier or an 8-ohm minimum amplifier, any load above 8 ohms is absolutely fine for it to drive. However, the higher the impedance, the lower the volume level that comes out. Say, for example, you wanted to deploy more than 2 speakers in an application. What you could do, and this is very difficult to describe over a webinar, is you could actually take the series speaker wiring diagram on the right-hand side and have 2 sets of those, which you would parallel into the amplifier. By paralleling 2 16-ohm loads, you're then reducing the overall load to 8 ohms, which is what the amplifier prefers to drive. So you're going to have the same overall volume level, and the amplifier is going to be quite happy with that application. But be warned, it's very, very easy to get speakers out of phase, and it's very, very easy to get series parallel applications confused. The other thing to consider when you're looking at series-based applications is, let me just bring up a pointer here, is if there is a break in any of this circuit, it means that both sets of speakers, or sorry, both speakers in this side are going to fail. Also, if a speaker is overdriven and becomes open circuit, which is generally what happens when people have parties, then this side of the circuit will fail. So actually, series-based applications aren't ideal. When we move to medium and larger installations, we start to use a standard called high impedance. This uses a 70 volt voltage in the US and 100 volts in the UK, whereas conventional residential audio would be using somewhere around 2.84 volts and up. So it's significantly higher voltage, and it works in exactly the same principle as electricity distribution does in the world. So the thing with sending power over cables is the higher the voltage and the lower the current, the further that the voltage can run over smaller cabling systems before there's any loss. So just like substations in mains electricity applications, where the very high voltages are reduced down to multi-phases, in commercial audio applications with high voltage, speakers generally have transformers or taps inside them, which step down the voltage locally to the speaker. So even though you're using 70 and 100 volts, and it's 100 volts in the UK, by the way, you won't get electrocuted. Common question is, why does America have a different voltage system to the UK for high impedance application? Very simply because in America, the standard mains voltage is 110 volts, and it would be too easy to get 110 volts confused with 100. And believe me, you don't want to be in front of a speaker when you connect it to the mains, and don't try that at home, please. That's why they use 70 volts. One of the reasons that you don't find high impedance used in home applications is because historically it's been considered to be less audiophile. I won't go through too much physics, but basically if you run any kind of audio signal through a large coil of copper wire through a magnet to be caught by another large coil of copper wire, which is exactly how a transformer works, then it's likely that you're going to see loss of audio quality, and that generally happens at the high end and the low end, just like it does with longer speaker runs. So traditionally, people don't use transformers or high impedance in residential applications, but more and more recently, actually, high impedance systems have become better for two reasons. One is that the introduction of Class D amplification, which is where a signal is oscillated by an amplifier, we can basically drive any impedance without the necessity for a transformer in the amplifier itself. So that means that we only need to worry at the speaker end, and at the speaker end, companies like Sonance have been working on making better and better transformers to reduce the loss of bass and treble over distance. So Sonance will argue that actually their full fidelity transformers provide uncompromised performance. Obviously, you're going to find over a distance that there will be a slight loss, but in commercial applications, it's not something that you're going to be noticing as an audiophile engineer. High impedance wiring is much, much easier because each speaker uses a tap or transformer, which chooses how much current passes to the speaker. All we need to do is run a parallel cable to all the speakers in the run. In larger applications, we might use multiple amplifiers so that we can have different volume levels on different change of speakers. You set the tap on the transformer to set the expectation of the power consumption from the amplifier, and that can be anything from 2.5 watts to 120 watts. And then you add together all of those loads to make sure that you still have 20% overhead available in the amplifier power itself. If you exceed that, you're going to end up with the amplifier clipping, speakers not sounding as they should, and potentially a reliability issue with the amplifier. If we look at the chart now and we take into account 100-volt speaker systems, then you'll see that even using a 16-gauge cable actually gives us the ability at 250 watts to run that cable up to 215 meters. And even with 1,000 watts, which is a considerable amount of current, it gives us the ability to run up to 53 meters. Again, you'll see the recommendation is generally to prefer 14 or 12-gauge cable for longer distances, but you can choose the cable gauge according to the application, taking into account the amount of current you're driving down the cable and the distance that you expect the cable to go. Also, what you'll find with high voltage systems is that you will have amplifiers which will have multiple outputs, so you won't be expected to run significant distances. What you can also do, if you have an application where you've got a long distance before the speaker change starts, for example, if you had a hotel which had an outdoor landscape audio system, then you can run a very high, low gauge, high wire section cable like 12 AWG to the first junction point and then use 16 gauge thereafter. So if you've got a long distance to run, use a lower gauge number cable and then break that out in a junction box like our own Son IP68 Pro, which will enable you to tee that out at a lower gauge, which is easier to work with and still gives you significant distance. Before I continue any further, I was just going to break off for some questions if we have any. No questions so far, apart from one from Jason Lawrence, who was asking when we're doing part 2 of the cinema training. Just to let you know, that's 10 o'clock on Friday for anybody that's interested. What I'll do at the end of this is I'll post a link to that so that anybody that fancies joining me on that on Friday can sign up and join the webinar. Okay, going beyond medium and large installations, we will be discussing a technology called Dante, which is one of my favorites. Dante stands for Digital Audio Network through Ethernet. And whilst the table on the right-hand side of the screen probably looks inordinately complicated to you right now, it is actually one of the simplest ways to distribute audio. Dante works at preamp or line level, and Dante technology is built into many, many devices, and all Dante products are interconnectable. In very simple terms, without any need for expert network knowledge, Dante distributes uncompressed multi-channel digital media over Ethernet networks with near zero latency. And when I say near zero, we're talking around 1 millisecond, which the human ear cannot hear. Dante enables us to connect up to 512 by 512 devices. And the easiest way to think of them is as if a device is a checkbox on this picture on the right-hand side of my screen. And imagine those checkboxes are phono connections. So in this case, I've got an amplifier which I've connected to a source, and I've simply connected it by ticking these boxes. And as soon as I do, those network Dante devices now connect to each other. So it's very easy to connect a device or a channel from one axis to a device on, or multiple devices indeed, on the other axis. And that's done through a piece of software called Dante Controller, which is free and readily available. Most manufacturers, including Yamaha, Sennheiser, Bose, many manufacturers have Dante products. And if it's a Dante product, again, it is compatible with any other Dante product, regardless of manufacturer. Dante can work over 100 megabit and 1 gigabit networks. I would imagine on any application you're putting in now, you're putting in the very least of 1 gigabit. It does not work over wireless networks. Those of you who did my ProNet introductory training last week will know that with wireless networks, latency is an issue because a Wi-Fi access point works in a clock cycle. Dante is real time and therefore intolerant to latency. One of the reasons it only has 1 millisecond latency is because it uses a wide environment. On Yamaha products, the Dante interface is embedded inside the same connection as the network connection to the device itself. If you wanted to use a PC or a Mac, you can actually buy a Dante sound card application, which means that you can route your sound straight through Dante. So that's a really good application if you've got lecturers, etc., using a conference hall or a seminar, because basically you can just put Floodwire Cat6 to the environment rather than complex audio signals. If you have extremely complex, busy or slow networks, it might be necessary to implement QoS, and Dante uses the same quality of service profile as VoIP. Finally, Dante products include microphones, sound cards, input modules, and Bluetooth plates. So going from left to right, this plate here actually is a 6-way Dante plate. So over a single Cat6, we have a Bluetooth connection. Let me give you an application for this. So if you have a gym and you have a gym instructor or class instructor that wants to use their phone, the process is as simple as this. You run a single Cat6 to the gym. The instructor presses the pair button on the gym device, which is just a wall plate, and it goes to Bluetooth on their phone and clicks pair. Then the audio from their phone is automatically transmitted to the Dante device on the network, so the mixer or the amplifier. In addition to that, we have a left and right Dante channel for input, a left and right Dante channel over 3.5 millimeter for input, and finally a left and right output channel, which you could possibly use for a local amplifier, for example. If your application doesn't have Dante enabled devices, there are Audinate, who actually developed the Dante standard, created these devices, which are basically either single or stereo, or 2-channel rather, input and output modules. These are PoE, they're very small inline devices, and they support either balanced or unbalanced audio. So they come as standard with XLR connections, and you can get XLR to phono converters for connecting a local CD player or streaming device. As you'll know, Habitech are a Sennheiser distributor, and we have digital microphone systems which again are Dante enabled, which can connect into any Dante platform. There are also PoE Plus and Ultra PoE amplifiers now available, which you can mount in a ceiling. They take their power off the network cable, and they also provide audio via a Phoenix output. This is a really good way to quickly expand a system. If you've got a category cable running, for example, to an extension, and you want to extend that out, you can use PoE and Ultra PoE network switches, compact network switches, to split that power out and connect not only your Dante amplifier, but perhaps Dante inputs and maybe control panels for that environment. And then finally, what's a really good application is at the point where perhaps in a commercial hotel environment, you want to add in something like a mixer. Imagine how much easier it is just to have a single Ethernet connection connection to that mixer, and that mixer to carry 16 or 32 channels of mixed audio. It's a really, really good way in applications like hotel facilities to be able to enable DJs to be able to use the system very, very easily without you needing to reconfigure it. So, system specification. We would always recommend you come to us for advice, specifically on your first installation. Commercial audio systems are very different to residential, and we're very fortunate to have an expert in John Perry, who's been in the commercial audio industry for 16 or so years, and he's been with many of the major manufacturers, which include Yamaha and Shure. We offer free planning consultation. If you can get plans of your application, all the better, because that's going to help us map things out. We can help you specify what video and audio devices you may need, speakers, where those speakers should be located. And for larger systems, we're happy to provide one-to-one configuration training. So you can book a session with us to either come in or online, run through an application. We can help you put together the plans and quotation for that, and we're very happy to do it. We've found that taking this approach has resulted in some really, really successful deployments from customers that would otherwise find putting in a large commercial installation very difficult and taxing. And we've provided on-site support for this as well. Few audio guidelines for you. Many of you probably use some kind of sound level meter for your cinema applications. You can buy handheld devices, and there are also some excellent applications for both the iPhone and Android devices. So the ideal sound level for normal conversation in an environment is between 55 and 65 decibels. To put that into perspective for you, 40 decibels is a refrigerator humming, 50 decibels is a quiet office, definitely not ours. 60 dB is a normal conversation at about 3 foot. And when you start to go 70 dB and higher, that's where you get things like busy traffic, city traffic, factory machinery, or subway trains. If you're deploying an audio system in a restaurant, the restaurant background noise range is normally between 65 and 85 dB. And it might be worth asking the restaurant owner if you can take a few measurements before you plan or deploy the system. It's very discreet and easy to do with a phone on a table or a small microphone, doesn't require external power. It's going to give you a pretty good idea of the environment that you're deploying or specifying the system for. You don't want exposure to audio greater than 85 dB in a restaurant or cafe environment. It's going to put the customers off, and ultimately at long term exposure, it can cause ear damage. Generally speaking, you would set your background music to deliver 3 dB above ambient noise. And again, you can very, very easily do this with a measuring device and a laptop if you're configuring a system, so that you can both set the minimum and maximum expectations to make operation of the system as easy as possible for your customers. You also want to set any microphone level for general announcements 3 dB above that, so it should be 6 dB above ambient noise, so that it draws people's attention to the announcement rather than becomes part of the background music. And as I said, you would use audio ducking or audio mixing to fade or reduce the background music while those announcements take place. In terms of software, there are 2 pieces of software that can help you plan a system. Both of these are free of charge and relatively limited because they don't necessarily take into account dispersion of audio on a horizontal plane. So the first is a product called Siska, which is a Yamaha product, and it enables you very easily to put in the dimensions of a room and then work out how many speakers you need to deploy. and where you need to deploy them. And it allows you to import diagrams of the environment, and you scale that diagram, and then you deploy the appropriate speakers, and it will tell you the listening levels that you will achieve. So you can put in a listening level expectation, and you can set the software to produce a speaker map. And you can use that map to support your documentation when you're providing a quotation to a customer. Because it's a Yamaha product, it only supports Yamaha in ceiling and surface mount speakers and subwoofers. But there's another application called Ease. And Ease is, again, you can see from the diagram on the right-hand side, allows you to import plans, put speaker placement on them, and then get an idea of what the volume level will be with appropriate amplification and speaker taps. Ease and Cisco are both Microsoft Windows only products. If you want to use it in a Mac, which I do, you can use Parallels, VMware, or Boot Camp. It works absolutely fine, even across networks. There's no issue with that. Sonance provide a free version of Ease. So if you intend to use their professional and commercial speaker range, which are really, really nice products, they're beautifully designed products rather than the ugly stuff you normally see hanging out of a commercial application, then their speakers are already populated in the software. And it makes it very, very easy to calculate and deploy. And in both of these pieces of software, you can use multiple types of speakers and multiple taps. So it even allows for you to set the volume level in different environments. I've just had a question from Ajabawi. What's the ideal volume for a cinema? Well, I'd recommend you listen to our, or watch rather, our Cinema Essentials webinar on Friday, because one of the applications there, I'm actually going to run through Dolby Atmos and DTS:X and how you should set levels in those rooms and the formulas for those rooms. Moving on to system components. Those comprise live equipment, audio sources, processors and amplifiers, user interfaces, for example, keypads, volume control, and apps, and finally, loudspeakers, the bits that make the noise. So I'm going to start with the Yamaha MA series of amplifiers, and these are really, really versatile, inexpensive amplifiers that give you a great turnkey solution for those smaller applications like bars and coffee shops. We start with the Yamaha MA 2030, which is a 60-watt mixer amplifier. It's 1U in height and it's half width. It has either 4 ohm or 8 ohm settings, so you can use conventional loudspeakers off it. You can also switch it into 100-volt line mode, so it's very, very straightforward to use for longer distance commercial applications. And what steps it aside from conventional amplification is that it has 2 microphone or line inputs and 3 stereo inputs. So it's very diverse. You choose from those 3 inputs what type of sources you want to use, and then you use this source rotary encoder here, to choose either stereo in 1, microphone in, or the phono connections at the back. It has a front-facing microphone input, which again has a rotary potentiometer to adjust volume, and you have a main volume setting together with bass and treble. Really, really straightforward for your customers to use. You can pre-configure it from dip switches for how you want to deploy it. Dip switches are at the back, and simply switch it on and off it goes. It's a Class D amplifier, so it's very, very hardy. It's passively vented. It has no fans. Really, really easy to install. As an accessory, if you wanted to increase amplification, then you can add another half-width 1U product called the PA2030, which is a power amplifier, and you can get a bridging kit which ties these 2 devices together, so they sit on one rack, 1U shelf, and then you have 2 volume levels for 2 sets of 2 rows of speakers. At the back of the amplifier, you'll see you've got your conventional IEC power inlet. You have got settings for whether you want 100 volt, 70 volt, 4 ohm or 3 ohm impedance. Don't worry, in 4 ohm mode, of course, you can run 8 ohm speakers. That's no problem at all. It provides a line output connection to connect to external devices, for example, the PA accessory product. And it's got your two stereo phono inputs and a secondary microphone input as well, with a prefix adjustable gain that you can set. If you only wanted to deploy one PA2030 in a rack, there is a half-width rack accessory available, which makes that fill a complete 1U. Or, as I said, you can tie the two products together. The bigger product in this series is the MA2120, and once again, it's a 1U product. It's got up to 8 inputs. 6 of those can be mic or line, and 2 of those can be stereo. It runs 100 watts into 8 ohms or 100 volts line system. It has a relatively simple DSP for both sets of outputs with separate bass and treble. Again, very, very simple to configure and for your customer to use, only exposing the things that you're likely for them to want them to use from the front panel. So you've got variable input levels for all of those inputs, which you might want to label, and then you've got 2 sets of volume outputs. What I didn't mention with the MA2030 is that you can use a DCP panel. On the 2030, you can only use 1 DCP panel, and on the 2120, you can use up to 2. I'll explain what a DCP panel is shortly, but basically that's an input and volume adjustment device. I've just had a question in from Thomas. How would we run subs off these units? Would we run them in parallel, or would we run them on the 100 volt line? That's entirely dependent on how you want to do it. So in commercial applications, you have woofers and you have subwoofers. So a woofer basically is a reinforcement of bass rather than the addition of lower frequency bass. So with a woofer, you would run that in parallel on the 100 volt line or on the low impedance line, as long as it allows you to. In the application for subwoofers in a single room environment, then I would be inclined to use a bigger amplifier like the MRX series I'm just about to come on to, and use dedicated amplifier lines for the subs, because that's going to allow you to adjust the subwoofer level critically according to the, or proportional to the output level of the speakers, because the speakers are a kind of separate entity in that application. Paul Oakes has just asked, do the amps have remote volume and source selectors? Yes, on the 2120 series, they have remote source selectors, and I'm going to run through that shortly. Okay, moving on. So the next step up is to use things like the MTX3 and MTX5D processors. And they look a little bit daunting at first, but actually they're very simple, and they're really comprehensive in what you can do. What I would certainly say is with any of the MTX or MRX series processors, please do not just take one out and install it, because they don't work out the box without you configuring them using the MTX MRX software. And there are 8 parameters per input that you need to set, which once you understand are very, very straightforward to do. But if you haven't had any training at all on MTX or MRX series, you're going to be a little bit in the dark. So the most popular processor in the range we sell, or the two, are the MTX3 and MTX5. These are known as fixed architecture processors. They're processors only, not processor amplifiers. We have an amplifier that goes with them, obviously. They have up to 8 mic or line inputs. They have an additional 3 stereo inputs, and they have 8 analog outputs. So off these devices, you can run many amplifiers if you want to, and they're scalable up to 26 by 8 matrix, 16 mono microphone or line inputs, 3 stereo inputs, 2 FX returns, which is where you can send the audio out and back in for processing, and finally 16 channel digital via the YDIF connection. So YDIF stands for Yamaha Digital Interface. It's a little bit like SPDIF, but YDIF can carry up to 16 channels of audio over a single patch cable. Moving up, we introduced the MTX 5D, and the big difference between the 5D and the MTX3, as you can probably see, is that the MTX3 is a 1U product and the 5D is 2U. That's because it has significantly more capabilities, and included in that are actually inbuilt Dante. So with an MTX3, if you wanted to deploy Dante, you would need to use external Dante devices like the Audinate products to convert from digital or from a balanced audio over digital back into digital and then into the inputs on the processor. Something that I'll come on to later, but it's probably worth mentioning to you now, is with commercial audio products, you don't see phono connections very often. That's why with even the MTX3, you've only got 2 sets of phono inputs. That's because the rest of the inputs are actually done via balanced audio connections. And I'll explain the advantage of balanced audio in a little while. But each one of these Phoenix connectors here actually represents 2 inputs. So we have input 8, 7, 6, 5, 4, 3, 2, and 1 here. And then we have output 1, 2, 3, 4, 5, 6, 7, and 8 here, which would go to your amplifiers. You can also use the YDIF connections to do that, and I'll explain that in a while. On the MTX5, as I said, it has inbuilt Dante. It also has YDIF. And you would use the primary network connection here, not only to provide a network connection for the MTX, because it can be controlled by iPads, Android, and it can be programmed from a Windows application. And there's also a secondary Dante connection, which you need to be careful with to stop network loops. But basically, because Dante is considered a transport for professional commercial audio in professional environments, they provide a secondary connection in case of network failover. Like the MTX3, you still have 2 sets of stereo inputs. You also have dip switches to configure how the device works. You can lock the device so that only certain functions are available from the front or none. And the other thing, again, which I didn't show you on the MTX3, is both the MTX3 and the MTX5 share a 16-pole connector over which you can use contact closure or rising high or falling low connections to trigger other devices. So for example, in our training room, we use a Yamaha MTX 5D connected to a Wirestorm video switch. And according to the source you select on the 5D, it sends a signal to the video switch, which automatically switches the video for you. Again, we can provide you with diagrams and application notes for this, but it makes things much, much more robust. Rather than relying on a protocol-based system, this is literally relying on voltage shifts to automatically switch inputs and outputs according to what's selected. The MTX5, through its 2U size, also gains what's known as an MY card slot, and that MY card slot provides compatibility to practically every commercial audio application out there. So you can get everything from an input expander card to a secondary Dante card to all of the supported standards out there like AES and so on. So the MTX5 provides you with a wider range of application. The MTX5 is also more scalable, so it can become a 34x16 switch with 16 mono mic or line inputs, 3 stereo inputs, 2 FX returns, and 16 channels of YDIF. Moving on, we have the MRX 7D, and the 7D is a much, much more comprehensive product. In most applications, you're going to find you're probably going to be using an MTX3 or MTX5, but a 7 really gives you an enormously configurable device with up to 110 by 104 devices on its matrix, which supports 16 mono, mic and line inputs, 3 stereo inputs, 2 FX returns, and 16 channel WiDiff. You also have the MY card slot, and you also have a Dante expansion. The MRX7D is definitely something you need to plan before you deploy because it's open architecture, so it can be deployed in practically any way you like, rather than a predefined configuration, which you get in the MTX3 and MTX5. To pair with those devices, we have a series of power amplifiers, and specifically I'm going to focus on the XMV series today, which actually are designed to pair with the MTX3 and MTX5. Obviously, this is usually a one-day course, and there's an enormous range of amplifiers and loudspeakers that are available from Yamaha to go with these products. So we also have very, very high power PA speakers and PA amplifiers that you can also use. But in this case, I'm going to take conventional applications rather than PA and discuss the XMV. So the XMV come in a 4140, a 4280, an 8140 and an 8280 variants. The 4 represents, or the 4 or 8 represents the number of output channels that the amplifier has. And the 140 means 140 watts per channel, and 280 means 280 watts per channel. They also come in a D suffix model. So the 4280D you can see in this picture means it has 4 channels of 280 watts and is Dante capable, which means you don't have to use any of the input connections. You can just use the Dante and configure it through the Dante Manager what processing device you want to be connected to that amplifier. And that puts us in a fantastically advantageous position with multi-area environments where you might not want to run significant speaker cables. In that case, you can just use a Cat6 network and locally, or store and cupboard locate things like a 4280D or an 8280D to power the speakers in that remote area. And don't forget that we sell fiber converters, so you can take that Dante signal over 1,000 meters if you need to. So you've got fantastic application opportunities. The amplifiers support both low impedance and high voltage. That low impedance and high voltage can be mixed across 2 sets of outputs. You can have digital and analog inputs to the amplifier. You can use balanced or unbalanced. You can use WiDiff, and they're also Dante. They're also network controllable, should you need to do that, but generally you would do that through the processor. And in the right-hand side of this picture at the bottom, you can see that I've got a remote connection, an MSG. The M represents mute, the S represents standby, and G represents ground. Should you connect S to G, the amplifier will immediately switch off. And should you connect M to G, the amplifier will automatically mute. That gives you the advantage of in commercial environments when you're having to interface with, because of law, with things like fire safety systems. You can very easily connect the two together without any level of programming to make sure that when a fire alarm goes off, the music stops. Also, we have a normally open, closed, and normally closed connector for a fault output, which can be used to trigger an alert to say that there's an issue with the amplifier. And on the front of the amplifier, if there is a problem, it will tell you through a code that you can look up on a table. So what you might want to do when you deploy this in a rack is just print a label which represents the 3 most common faults here. Which might be that the network switch is switched off, for example, so that it gives your customers an idea of what's going on if there is a product failure or a sound failure. The other advantage is if you're trying to diagnose a fault remotely, it's very, very easy for a customer to give you a fault code, and then you can look at your plans and work out what that might be. So in terms of amplifiers, we have the 4140 all the way through to the 4280D, and then the 8140 to 8280D, which are the 8-channel variants. And you'll see they both provide either 140 or 280 watts per channel. There are Dante versions. All of the amplifiers are the same height, and the SRPs run from £1,004 all the way through to £3,341 plus VAT. I mentioned earlier the DCP and MCP panels. I just wanted to run through those with you. DCP, these are basically 1-gang and 2-gang control panels which fit conventional UK single and double back boxes. When you're putting in single or doubles, please put in 35 deep, which is the standard these days anyway. And they come in 3 models with combinations of switches and knobs. So in the simplest form, the DCP4S gives you 4 switches which you can configure using the software to carry out practically any command on a processor. When you use it with a simpler product like the MA2030, then those input plates will basically select the input remotely. Moving on, you can have the DCP1V4S, which is where you have a single rotary encoder and you have 4 buttons. This would be where perhaps you would want to have selection of input and adjustment of volume. Again, this is very, very useful to put in bars and environments. You don't really want to be putting things like 2030s and 2120s in the bar area where they can be adjusted, because people are just going to pour Coke and beer over it. So what you can do is put the amplifier in a hidden location, and you can just have one of these exposed for, or 2 of these exposed for the your customers' staff to use. Very, very simple to deploy. You simply connect them using a category 5 or category 6 cable. They have in and out connections, and they have dip switches on the back to configure them. And then finally, we have the DCP4V4S, which is where you have 4 switches. These don't have to select inputs on the MTX3, 5 and 7. They can do other things. They can recall presets, for example. And then you have 4 volume encoders where, again, you don't have to adjust volume. You can adjust input. You can adjust a certain area, etc., etc. You can really configure this to do whatever it is you want. Very important to let you know that only the DCP1V4S is compatible with the MA2030, which is this model here, where you can adjust the volume and input selection. Cabling is very straightforward. You can daisy chain or star out these devices. They actually don't use any network protocol. They run on a balanced serial connection, which is proprietary, DCP. And there is a maximum distance for that cable, but it's significantly higher than it is with conventional networking. So if you were to use a star-wired connection, you would need to use a DCH8, which would have a single connection to the MTX3, and then you can have up to 200 meters to each one of these panels. However, if you wanted to daisy chain them, according to the amount of devices you have, you can actually have a significant distance. So if you only used 4 keypads, for example, you could actually have an overall distance of 400 meters, or a single panel can be up to 1,000 meters away from the processor. Before I go on to the MCP, I just want to jump back to the MTX3 and 5 and say to you that on the front panel, these devices also have an SD card slot. And on that SD card slot, you can put audio files, which might be an announcement, a standardized announcement, for example, or music files. And you can recall any one of those music files very, very easily, either by a programmed preset or, in fact, by a button on the front of the keypad. So they're very flexible in that sense. I'll come on to that a bit more in a while when I talk about wireless DCP. I've got a few questions coming in. Let me just have a quick look. Paul Oakes has asked, do the amps have remote volume and source selectors? Yes, they do. You can remotely control them, but generally speaking, you would use the MTX or MRX to control them and actually use them as power amplifiers. But yes, you can remotely control them, and there are applications and APIs to do that. Thomas Baxter has said, nice product, thank you very much. And let me just scroll down the screen. Ajibari says, can we use the MTX3 for audio distribution? Yes, you can. So it has, so in the case of the MTX3, let me just scroll back up to it. So with the MTX3, it is up to a 26:8 matrix, and you have 8 mono outputs. So yes, you can use it for audio distribution, but you need to add an amplifier for it to function. Doesn't have to be a Yamaha amplifier, but Yamaha amps are recommended because obviously they'll auto trigger, etc., off the MTX. So moving on. We also have an MCP option. Now, what I didn't explain with the DCP is that you can only ever have a maximum of 8 in a deployment. And with the MA2030 and the MA2120, you can only have a maximum of 1 on the 2030 and 2 on the 2120. On an MTX or MRX system, you can have up to 8 panels. But there may be applications where you need more than that, and one option is to use the MCP. So the MCP is a programmable keypad. We use one in our training room, and it has a, let me just get my laser pointer up. It has a home button, which always takes you to the front screen, and a back button, which always takes you back, and then 6 programmable buttons. And all of this text is completely programmable to your requirements. So one of the nice things about the MCP is that it's something that you can automatically label. And you can have up to 6 pages, which can include things like source select up and down or volume up and down, as well as key specific functions. And any one of these labels can jump to any other page. So actually in a main bar, it's a really great way to control multiple areas in that bar and perhaps restaurant. It runs on PoE, which is great. So you can just plug it straight into a network switch. Obviously that means it's restricted to 100 meters in copper, but using fiber extenders and a PoE injector, that can be up to 1,000 meters away. You can have up to 16 units. That's 16 units in addition to the 8 DCPs you can have. The display is multilingual. As I said, you have up to 6 pages of control, which actually gives you up to 36 functions, and every function is individually labeled. Very important to say, the MCP is only compatible with MTX and MRX processors. In addition to DCP and MCP, if that wasn't enough, there is some fantastic software available. This again is only available for the MTX and MRX. Comes in a version for iOS, which is designed for iPads of any flavor. And it also has a variant called Wireless DCP for Android. And in this application, you'll see that I've been using the iPort frames. So this is a surface mount with buttons. You can also get a surface mount which doesn't have buttons. And in the Android instance, this is a Flow 7 frame, which is a Samsung based tablet. So on the iPad, you have an application called Provisionaire, which is really, really great. There's a Provisionaire software for the PC, but in fact, you can configure it just using the iPad itself. There's 2 variants, Provisionaire Touch, which is for you to configure the system with, and Provisionaire Kiosk, which is the user version of the software and doesn't enable them to do anything but control the system. You can set any background wallpaper. So this picture you can see here is actually a demonstration facility. And probably by showing you what I've done in our demonstration facility, you can see just how flexible it is. Because what I've done is I've chosen 10 different presets, which can be immediately recalled. The MTX and MRX integrate really well with the Yamaha MusicCast products. So you can add 120 quid WX-AD10 to an MTX3, for example, and you can recall radio stations and specific playlist presets, or you can recall SD card functions from the front panel SD slot on the processor. And then I've made various buttons to increase and decrease volume. And in this case, I've actually made hidden buttons which enable us to switch on and off speakers for demonstration. So that gives you just a relatively simple idea of how flexible this is. You can use your own graphics, you can use predefined graphics, and you can lay the whole thing out just using finger touch on the iPad. And when you've finished designing your page, you can save that. And the fantastic thing is, if you've got a customer that's hundreds of miles away, you can actually just click an export button, which will email it to the customer. And when they open their email on the iPad, it'll automatically update the interface on their system. So anytime if your customer has any requirements for change, you don't even need to do a site visit to update Provisionaire to their latest requirements. Important to say that Provisionaire is only available on iPad. It's not available on Android. On Android, instead, we use a product called Wireless DCP. And Wireless DCP is a slightly simplified version. It's another great way, though, of adding control behind a bar, because you have the ability to label buttons and carry out functions on those buttons. You can have multiple pages, and you can adjust sliders to adjust volume. In some ways, you might find this application a good complement to DCP panels, because it's got very, very simple and easy sliders for people to be able to understand. And of course, because it's running on an Android device which is perpetually powered, there's no worry about it running out of power. And it's quite hardy because, just like the iPort products, this is an anodized aluminium frame. Just like Provisionaire, Wireless DCP can also be locked, so the users can only fiddle with the things you say they can, like volume level, and you can set upper volume limits. Okay, moving on to installation and setup now. Couple of fundamentals. When you start to deploy commercial audio products, you'll find that actually there are many standards that are the same between brands. And I would say it's very important to make sure that you have a stock of spare Euroblock or Phoenix connectors. There are two flavors that are used. There's the smaller pitch product here, which is used for inputs and outputs on the in-out function on the MTX and MRX. And for audio, both of those products use a 6-pole Phoenix connector. Make sure you carry spares of these. They come in the box, but of course, someone will throw away the box before you get to site, and you're going to be absolutely scuppered without something. At the very least, if you're deploying a system before it's going to be wired, then try and put the Euro blocks in the back of the connectors so that they don't get lost. Then when you carry out speaker terminations, you need to make sure you're using a suitable termination tool. I'm going to send you some information on some recommendations for this. And just like with mains electricity, you want to be using a 3.7 mil spade. Sorry, when I refer to mains electricity, I mean that according to the gauge of the cable, you have different colored collars, and the crimp tool will crimp appropriately to those colors. In this case, I've highlighted blue and yellow because yellow is a 10 to 12 gauge. There's a typo there, 10 to 12 gauge cable, whereas blue is a 16 to 14 gauge cable. So generally you're going to be using yellows and blues. Connecting the processor to the amplifier, there are 3 methods you can do that with: balanced audio, YDIF, or Dante. If you're using balanced, I'd like to do a little bit of an explanation about balanced. The reason that we use balanced cables instead of unbalanced, so unbalanced would be something like a phono cable, is because with phono cables you have a persistent ground and a signal connection, and over distance that can often cause hums because the amplifiers or processors are on different earth levels according to the mains. Unbalanced signals are also tend to pick up noise and EMI more than balanced cables, or much more than balanced cables do. So the way balanced cables work is they do have a persistent ground connection, but actually the signal is split into a positive and negative connection. So when you're connecting the Phoenix connector, we'll just find the back of an amplifier to show you. When you're connecting the Phoenix connectors here, you've got a plus, a minus, and a ground signal for each input and output. When you're connecting inputs to into an MTX system and you're using something like a CD player and you're not using the phono connections, it's very simply a question of connecting the shield of the phono connector to the ground and then connecting a small pin of wire or a staple between ground and minus, so that the minus input level has a reference point, and then you use the signal of the RCA as a plus. So there's no reason for you not to mix balanced and unbalanced connections. You just need to make sure that when you put unbalanced into balanced, you make that interconnection there between ground and minus. Finally, I'm just going to show you a screenshot of the MTX MRX editor. And this is where you'll see you can adjust everything from inputs to how those inputs are matrixed, to zones, routing, outputs, effects, and finally connections between the main processor, any external connections, and XMV amplifiers. And very simply, it's a matrix software, so you can adjust volume levels and inputs, you can adjust output levels, and then in the controller page of the software, you can do things like setting up keypads, network connections, etc. The big difference about the MTX MRX editor is, well, first you have to use it to configure either an MTX or an MRX processor. But secondly, it will work in both an online or an offline state. So when it's online, next to each of these sliders, you see peak level meters, and it makes it very easy for you. You can see them there just about. It makes it very easy for you to understand what's going on at the end of your environment. Quite often when we're helping customers configure systems, we ask them to have a laptop on site so that if they're issuing or seeing a problem, we can see what's going on with the peak level meters, and then we can go through the configuration to see what it is that's not working appropriately. I'd highly recommend you come back for one of our MTX MRX walkthroughs. And what I'm going to do is I'm going to give you some links to some really, really good Yamaha training on the MTX MRX editor, and they're going to come out at the end of this webinar, as I said, within the next 2 days. Finally, I mentioned, and I'll give you links to the Sonance Professional Series speakers. Sonance make in-wall or in-ceiling pendant series and surface mount series speakers for every application, right the way from conventional restaurant and bar applications through to industrial or clothing shop applications like these pendants, or perhaps high ceiling venues, to finally not only surface mount speakers, but surface mount speakers that are very tolerant to humidity and water. And they also make outdoor application speakers like landscape, garden series, and patio series speakers, which means that you can expand systems outdoors. That's one thing that is fast becoming a big application in the commercial space, is the deployment of outdoor speakers in restaurant environments. And again, it gives you another ace up your sleeve when you're specifying the installation to have all of these products to hand. Of course, we will help you with plans, as I said, on any system you want to deploy, and on larger systems, we're very happy to provide one-to-one training. I'm just going to have a very quick look. It's the end of the training. I just want to have a very quick look at the Q&A board. Haven't got any further questions. I'm going to leave those questions open for a few minutes, and then I'm going to close off the training. Thank you very much for attending. I appreciate that we've been going on now for nearly an hour and a half, and there's a lot to take in, but I hope you enjoyed it. Thank you very much. I've just had a question from Divyang. This webinar, is it recording? Yes, it is. We record every webinar that we do, and you will automatically be sent a link to this tomorrow morning. Thank you to Stuart, Thomas and Jason for your feedback. Really appreciate it. As I said, if you do have any more feedback or questions, do use the training@habitech.co.uk email address. Please, though, bear with us, as obviously with COVID-19, we are running limited resources. Question from Ajay Bowie, what is speaker amplifier matching? Well, it really depends on the application. Again, if you can give us an idea of what it is you'd like to do, then we can help you match the appropriate speakers. Another question from Russell Minier. If a customer has existing ceiling speakers, which are 15 years old, is it worth replacing them for new ones? Well, obviously, if your customer has the budget, yes. But don't forget that the amplifiers I've showed you, every single one of the amplifiers I've showed you, is compatible with both the 100 volt, 70 volt, and 8 ohm standards. Will also drive anything between about 2 ohms and 16 ohms. So you can leave those in place. Probably from a commercial perspective, I would say focus your budget on the equipment itself rather than the loudspeakers. And then once the customer's happy with the system, recommend how that can be expanded or updated appropriately. Certainly, one thing I would say is that the quality of speakers like the Sonance Professionals series are significantly better than a lot of the older commercial speakers that are out there, and even ones from competitors. So it's something to look at. That seems to be the end of our questions today, so I'm going to stop the webinar there. As I said, you'll get a recording. Do send any questions to training@habitech.co.uk, and thank you very, very much for your attendance.